right, everybody. So thanks so much for coming to our talk. We're going to be talking about develop all the things with Docker. We'll get a little bit into what we mean by that and what we're looking to accomplish with our talk in a little bit. First of all, we just want to do some brief introductions. So my name's Forrest. I'm a senior software engineer at Docker. I'm the inventor of Docker init, which we just heard about in the keynote. So that was cool. And working with the next gen builds team. And I'll let Djordje introduce himself.
Yeah, and my name is Djordje Lukic. I'm a software engineer at Docker. I work mostly on the open source parts, so Docker CLI, and also the Docker engine, so Docker D that you all, I guess, use, I hope.
Yeah, he just forgot.
You don't hear us? You don't hear me?
Oh, go again.
Can you hear me better now?
Yeah, go again.
Yeah? You want me to repeat? So yeah. No, okay. Let's move on.
All right, we're good. Yeah, one of the qualifications, or one of the things he does at Docker is just be a superstar. He didn't say that though, so we're glad to have him for this talk. All right, so what are we looking to accomplish with our talk today? Usually, at least from my experience working with developers, when you think about needing to make an image or containerize, is thinking about production, thinking about deploying somewhere, right? So you think, well, how do I make that production image? Well, what we're talking about here is really how do you containerize your tool chain? Does it make sense to start early in your development cycle with containerization? And that's what we're hoping to talk about today, to show some of the different ways that you can accomplish that. What are the benefits of doing so? And because I guess we like to live dangerously, we're going to do it mostly through demos, so it might go horrible. We hope it'll all work, but it'll be a good time. So we're going to start off, first of all, with that first question. Well, why would you want to do it? And we'll turn it over to Djordje.
Yeah, thanks, Forrest. So yeah, why should we Dockerize our development environment? So we put up some of the things that Dockerizing gives you. So the first one is if you Dockerize your environment, it can be repeatable. I used to put here reproducible, but like reproducibility, it's hard to pronounce, and also it's a hard thing to do well. So reproducibility is like being able to build your image and then build it a year later, and then it's the same image bit by bit. But you don't really need that when you're in your development environment. What you need is for it to be repeatable, so that you have a way to unify your versions of your tools that your developers are using. So it's repeatable or reproducible enough, I should say. So it's also shareable. Yeah, everything that Docker does for you is shareable at the core. So you write a Docker file, you put it in your Git repo, and you can share it with everyone. They can use a Docker file to build the same image that you have. Compose files, you have your stack. It's just a YAML file that you also put in your Git repo, and you can share them. And yeah, you can also just build an image, push it on Docker Hub, and everyone can hopefully run them locally or in production or in CI. Dockerizing also helps with onboarding new people to your project. Because basically, if you have pretty much everything Dockerized, you only need one tool, which is Docker. So they don't need to go install Go, go install Java, or NPM, or the right version of all of the tools. You only have Docker, and it works for you. What else? So yeah, if you Dockerize your environment, it's CI ready, because you have one source of truth. So what you're running locally is also running on the CI. And hopefully, maybe some of the parts of it also can work in production. We'll see a little bit later in the demos. Docker has some powerful caching. Sorry, powerful. It's hard to pronounce. Powerful caching capabilities. Once again, when done right, you need to know your tools to be able to use the caching that Docker gives you. And also, finally, it's flexible. This is my biggest feature that I love at Docker is that you can use it pretty much any way you want. So you make it so that Docker works for you and you don't work for Docker. So yeah, you can use it like, you can use Docker build, Docker run. You can use it to compile your codes, to run your tools, or to run your things in production. So it's really flexible, and you can use it pretty much however you want. Um,
All right. Thanks
Forrest.
so much, George. So just one of the things I forgot to mention when we're talking about Dockerizing your tool chain, in this case, you may have heard of some technologies that are being developed right now. Like Docker has their development environments, and that's great. There's also like Microsoft is working on dev containers, which integrates really nice with VS Code. So those are all good, but we're actually going to be stepping back from that and talking more about using Docker primitives, images, containers. Going to show a little bit of Compose, and it'll actually help you use those other tools better if you decide to. But that's going to be the goal here, and probably talk about some of the gotchas as we demo as well. So as we mentioned, it's going to be kind of demo heavy from this point on. So we're going to turn back to Djordje with the first kind of approach that you can take with Dockerizing your tool chain.
Yeah, so yeah, it's demo time, and please cross your fingers, touch wood for us, because some of the demos need a working Wi-Fi, so we'll see how everything goes. So yeah, the first demo I want to show, there's no code, but who here is like a backend developer? Who works with databases? Yeah. So yeah, when you have a backend, usually you would have a database. So one of the first things you can do is just simply Dockerize your database. So how do you do that? Well, okay, this is you can simply just run your database. So I'll try to run Docker run MySQL, for example. Yeah, just a quick aside. Do anyone knows why it's called MySQL? So it's not because it's like yours or mine. It's because the creator of MySQL has $3. So it's my, Maria, and something else. And so he created MySQL and MariaDB, and the third one also named by the name of his daughter. So I think that's a cool little info there. Yeah, so let's try, does everyone see? Do I need to make it bigger? On the back? OK, yeah. Let's try to run MySQL. OK, so it doesn't work. MySQL tells me, well, you need a password for the root user. So I'll do just that. So I'll just -e is to add an environment variable for the container. So I'll put this one, and I'll put a really strong password here. So we're talking about development environments. So don't stress too much about, like maybe security and everything. That's for production and for infrastructure people. For local things, you can, of course, start simple. So if I do this, I'll just do one last thing. MySQL open support, and it's port 3306. How do I know that? I came prepared for this talk. But if you Google MySQL port, it will just show you that it's 3306. And I run MySQL, and it spits up a lot of logs. There you go. You have now successfully Dockerized a small part of your development environment. So, of course, next step is to go and update your resume and say that you know how to use Docker. I just want to show you real quick that this actually works. So I have dbeaver. I don't know what it is. I'm not working with databases that much lately, so I just found this one, and it kind of works. So I can see here localhost. I can see my databases. I can even create a database, DockerCon, and say OK. So yeah, you create a database. So we have a database locally. We didn't have to install anything, and it works. And this is actually, when I started using Docker years ago, this was all I did with Docker, which is just run a MySQL database and use it for my local development environment. And it's give me just a sec. I'm just going to stop this one. Starting slowly with just like simple things like this is also nice because, OK, well, you managed to run a database with Docker. There's an issue with this command, though, because if I stop my container and then rerun, you lose all the data. So then you go and look, oh, how do I persist my data? So then you learn about volumes, and so you learn as you go. And yeah, I cannot stress enough. When you want to Dockerize your development environment, start small. You don't have to have everything perfect the first time and everything working inside the container. It's fine if you only have a database. it will be that much easier for all of the developers to use the project and the database with it. Right. My next demo, I have here a small Golang, because yeah, in Docker, everything we do is in Golang. So I have a small Golang project here. Let me show it real quick. It's a small little Echo. Echo is a Golang web framework. So basically what I'm doing is I'm creating a new Echo application and then tell it, okay, when someone makes a GET request on / you return this string and then run on this random port. Let's see if this works. So if I go run my application, yeah, it says, okay, the server started. And if I go to localhost, hello DockerCon, okay, so my project works. One of the things you want to do when you're developing is, okay, well, you want to run your application, you want to build it and everything, but there's also all the things that you do around with your code, which is like linting, testing, and what have you. So I'm going to show you how can we lint this, and then how can we Dockerize the linting stuff. So in Golang, we have this tool that's called Golang CI lint. Then you can run it, and it will tell you, oh, look, you have an error in your code. I'll show it to you later. So yeah, that's great. We can run Golang CI lint, but then that means you need to tell everyone, oh, you need to install this version of Golang CI. Then no one will have the same version. So let's see how we can use Docker to do that. We can, of course, as with MySQL just before, we can do a Docker run. So if I say Docker run, now the first thing you need to do is to give it a volume. So I want to share my current folder where my code lives, and I want to put it inside a container in /app, for example. I'm also going to say, okay, your working directory will be /app, and then the image is Golang CI lint, and I'm going to give it a version. So I'll use the one 53.3. And now we need the command, Golang CI lint. I guess it's run. So with this, we can do the same as before, but now we also have a version, so everyone will use the same version. So if I run this, first thing you'll see that it's slow. It works. This can be your first step to Dockerizing. It works, but it's slow. Let's see why it's slow. So I'll just let it finish. So that's one of the biggest, at least for me, issues. It's not an issue, but it's when you want to Dockerize things, you need also to know your tools. So for example, you need to know that when you run Golang CI lint, it will actually download all your dependencies, put them in a cache, so that it can lint your code. And it also has some build caches and everything. So let's see how we can see what caches it creates. So I'm going to change a little bit my command. I'm going to tell it I want to do it interactively. And I want, sorry. OK, again. I want to run it interactively. And instead of running the lint, I want to open a shell. So I'm here. I can see my application. And of course, I can Golang CI lint and run the linter inside the container. Let's wait for 10 seconds. While it's doing that, I'm going to open another terminal. So if I look at Docker PS, so here's my container where I ran the linter. What I can do now is use this Docker diff command. So I'm telling it, okay, give me the diff of this container. And so the diff will give you the difference between the image and what's running inside the container. So if I do /less, you'll see all of the folders that the Golang CI lint created. So we have /root some caching, which is the build cache. And if I go down,
all the way down. See, it's doing a lot. Yeah, so we have the root cache, and then we also have, let's go. Yeah, there's the Go module package also cache. So basically, in order for our Docker run command here to be quicker, we can use volumes and then mount the volumes in the right folders so that on each new run, Golang CI can reuse that cache. So I've created already some volumes here. So if I do volumes ls, volume, I created two volumes, one for the Go cache and one for the linter cache. So I can now change my command and give it, so the first volume is the Go cache in Go package mod, I think. And then the lint cache in /root.cache. Okay. Now it's way, way faster because it doesn't need to download everything. Let me just show you that this actually also really works, because like if I remove now my call to the test function, so yeah, it was complaining because I was calling a function that returns an error, but I didn't handle the error. So if I fix now my thing, and if I run this, everything is fine. Let me just go back to this. Right. So we have this huge command. What you would want to do is maybe create like a makefile. Where am I? Yeah, maybe here. You can just simply put your huge command line in a makefile, and then when someone else needs to run the lint, they can just say make lint docker. So they don't need to know how to run everything, because you can set it up for them, right? Another thing that you can use, because like, okay, we run containers here, but there's another way you can run containers, and it's with build. So basically, instead of having this huge command line that you put in a makefile, you can put all of that in your Docker file. And so let's see how that works. I have, if I can find it, yes, I can, in the tool, have a Docker file. Okay, we'll talk about this later. I have this Docker file, and I created a lint target. So what it's doing, it's taking the same image, which is the Golang CI lint with a version. I'm telling it, okay, this is your working directory, same as before. I'm mounting, this line is like mounting your code. And build-kit so Docker build has these mount types of type cache. And so I have the same two directories here that I want to cache. And then I just run the Golang CI lint on my code. Right. So you can use this. You can say Docker build. I wanted to build my target lint that I set it here. And that's all. So we've used now build to run our lint. So let me just show you now if I fix my error here. So if I remove, if I remove this, and if I rerun, it runs. So if I run now, so look at this line. So here it's running. Okay, if I rerun, now it actually didn't run anything because the code didn't change. So why should you rerun your lint? So that's what I was saying. Like the caching build-kit gives you this powerful cache. So if nothing changes, you don't have to rerun your tools. There's one issue though here. If you look at all of this at the end, because at the end build-kit, when you Docker build, it's mostly for building images, right? But in this case, we're just running a tool, a linter on our code, and there's no need to create an image. And so you can actually tell to build-kit that you don't want an image. So the way you do that is by saying, okay, I want my output to be of type cache only. So the only thing that Docker build will output is the cache. So if I run this, once again, everything is cached, and we don't see anymore the export image part that we saw here. So basically, this is kind of what you want to do every time when you want to Dockerize some tool that you want to run against your code. Use a Docker file, mount your caches. You need to know where your tools create the caches, and then the last bit is the cache only. That way you have a very optimized way to run the tool. Awesome. Let's try maybe also to build an image, because I mean, Docker is all about images and containers. So I have here in my Docker file also another build target where I'm using my Golang image as my base image because I want to build. We find the same mount types that we have here. And then I'm just, go build of my image. So I can now say docker build -- target. My target will be actually the image one. Image. And I want to tag it as DockerCon and test there. Okay, so normally you should have created the DockerCon image, so I can try and Docker run. What's the 1323, 1323, DockerCon. Okay. Still works. So yeah, of course, you can also Dockerize your building things. And one last thing I want to show is, okay, so this creates an image, and the image only contains the binary of your application. One way also you can use Docker build is to not create images, but use it to build, to only build your binaries. So what you can tell it is same as here. Okay, I want to Docker build my image, and instead of giving it a tag, I can say, okay, my output actually this time, I want it to be bin, for example. This will be the bin directory. So if I rerun this, I can now, if I look at my code, it created a bin directory, and inside I have my binary. So you don't need to use Docker to just like run containers. You can also build binaries with them. And so I can even try to run. Okay, there's an error. What is going on here? So containers run on Linux. So what this build did was, if I look at what this file is, so it's actually a Linux binary. And I can't run Linux binaries on a Mac. But you can actually work around it. So the way you do this is, so you can say, okay, when I Docker build, I want my platform, platform to be Darwin ARM64, because I'm on an ARM64 Mac. This doesn't work, and it basically tells you, okay, here's the error. The issue here is that Golang the image only exists for Linux platforms. So what you need to say here is, okay, I want my Golang to be for the build platform. So essentially this is saying, okay, pull the Golang image, but for the platform you're building in, which is Linux. And then I need to tell also Go to build for the platform I want. So the way you do this is you say Go OS. Okay, wait, I need to first say, okay, and there's a target OS, and then there's a target arch. So I can say, okay, my Golang OS is the target OS, and Go arch is target arch. So when I run this, this will be, of course, the Linux ARM, and the target OS and target architectures will be taken from my command line here. I have this platform Darwin ARM64. Now if I, oh no, it's not, sorry, it's not end, it's arg. Arg. Right. So this is basically telling Go, okay, cross-platform build my image, my binary. And so if I look now at the binary that was created at the end, it's effectively a macOS binary and should work. Right. I think that was my last demo.
Yeah.
Yeah, it was. Okay. So let's just quickly recap. So what did we learn? I mean, I hope someone learned at least some things here. So the first and most important thing for me actually is, start small. It's fine if it's not super optimized. It's fine if everything is not inside Docker Desktop. Like I said, if you only have your database, it's good. Like, it's a first step. So Docker can also be used to run tools, build binaries for you. There's no need to only build the images that you push and want to run after. That was my part of the demo, and I'll leave you with Forrest now.
All right, so we're going to keep on building on this, and we'll take a look at something else. And hopefully my demos go as well as yours. You did great. Thank you. OK, so we're going to look now at Docker Compose and where it comes in. So we're going to take the exact same things that we've already learned that we use with Docker Run, and we're just going to use Docker Compose to instrument it. Basically, because Docker Compose is so great, because most of the time development isn't just you working on one thing. You usually have to bring in another API or some sort of a database if you're working on the back end. You end up plumbing all these things together. Well, Compose is great to set up a local version of that. We have a small demo application here that has two things, an API and a front end, and we're going to use Docker Compose not just to test a final production version of it, but really to be able to develop both of them simultaneously. So that's going to be part of the key of what we look at. You're going to see a lot of things that we've already mentioned so far. So I know for me, when I started developing with Docker, one of the questions I always had, which we've already highlighted, is how do I get my source code into the container that I'm working on? And so we're just going to continue to use bind mounts, and we're going to loop back and look at another way that we can do this. But you notice here in Docker Compose, we're defining for our API a bind mount, saying, look, the API directory, which contains all of our code for this Python API now, because again, we said we can develop all the things with Docker, so we're going to show off a couple different things. So bind mounting that API directory into application, and we're going to work from the app. And then the port that we know that we need to open, again, so that we can communicate from the host to our container, we've done bind mapping there as well. Very similar for our web app. So we've got a front-end application we're running as well. We're going to do the same thing. We're bind mounting the web directory. This is where we have all of our source code that's using TypeScript. It's React, using Vite. And that is going to be bind mounted into the app directory inside the container. One little thing to note here, this is kind of an interesting little hack. So if you are a front-end developer and you're containerizing your toolchain, this is a great line to remember. You always want to bind mount app node modules just to not bring in node modules from the host. It's almost always going to be wrong, and it's really going to slow down that initial transfer. And we'll show the Docker file just in a second how we built that up. And so same thing, right? Bind mounting our volumes, bind mounting our source code in, setting a working directory, and using ports. So let's take a quick look at our Docker files here that we ended up using. Try to keep it nice and simple. Once again, we kind of use this idea of starting small and building up. So for our API, it's a Flask API, and we know that we're going to need Python. We've kind of pinned the version here, so we don't have to worry in the future about rolling back to a different version of Python if our system upgrades, which happens all the time. I used to do Python development, so it's nice to have that. We're using this as our base build target. We are going to bind mount in. Again, it's kind of setting up that base target and using this bind mount type. We're going to bring in the requirements.txt. And then all we're going to do, also bind mounting our cache, as we mentioned here, we're just going to do pip install our requirements. So what we've done here is our base is set up with the tool chain that we need to run our application and the package dependencies. And we're good to go. That'll all be cached for us. We won't have to build it unless requirements.txt changes. At that point in time, we'll rebuild it. Now, our development environment that we're going to be running is using base. We're going to add on to that. And this is just using that containerized tool, Flask, in order to run our application. One other thing that used to bite me a lot when I was developing like APIs, started developing APIs with Docker is I would use the normal command like flask run or npm start for a node application. And all of a sudden, I couldn't talk from the host of the container. It just wouldn't listen. Well, why? That's because localhost for the container is inside the container. And it's only listening for things coming from localhost. So that's why you'll often notice these things like, oh, I'm listening on 0.0.0.0. Basically, what you're saying is you can accept requests from any area, not just localhost, because the host is really not localhost for the container, right? So keeping some of these things in mind. Let's go back and look at our compose file one more time here. So this is where we're using build. So we're setting an image name that we're going to use, called it no-watch, because we're going to show another nice little tool that was just released in the latest version of Docker Desktop called Compose Watch. But we'll come back to that. We're doing things the older way first. So we're just saying, look, we're going to build just like we were running a Docker build command. We're going to use the directory as our local context. We now want to build that dev target in our Docker file, and our Docker file is there. We're doing the exact same thing for the web front end, so just continuing to go down through this relatively quickly. We'll look at what the Docker file there looks. So even for front-end developers, this is great. I know, again, having done front-end development, you find out that your node is wrong. You usually end up installing another tool to be able to jump around on different node versions. And there's also a lot of things happening when you do an npm install that depends on your host system. A lot of things end up getting compiled against native libraries. Containerizing solves so much of those headaches. So let's look at how we set that up here again. With our base, we're caching. We're bringing in the package JSON, so we'll just have our basic tools, our runtime, along with the package dependencies that we need. And then finally, once again, we're setting that as 0000 because we're listening on we're listening from all IP addresses, and we'll just run yarn dev. Let's go ahead and see how this works. So we're going to, oh yeah, I told Djordje I'm going to mess up with this a lot. So yeah, I'm weird. I run Dvorak, and I can't type unless I switch over. All right, I think we're good now. All right, so we're going to run docker compose up, and there, it ran both the API and the web. But as we mentioned, this is not just running the final application or a production version of these images. We'll show that real quick. So if I were to go, just 1 second here, so it's 5173, and in the
4.
Oh yeah, thank you. Yeah, 5735, right? Is the app 5735? Okay, so let's see if I can figure out how to use a Mac here. Okay, localhost, and it's 5735. So here's our avatars API and the let's see here, command minus. All right, I'll make it a little bit smaller so that we can see the stuff. Yeah. Okay, so this is our little API. It calls off, gets some random things, generates a random API. But are we actually running live? Let's do a couple edits here just to see. So if I were to go to our app, we're going to add a feature. Okay, and I'll go ahead and save. Now this was the API changed. And of course, Flask is what's running in that container. So it just picks up the change because we bind mounted in the code. So it detects that code changed, and it's just going to restart. And if I were to refresh this, you'll notice that now we get yet another little section from the API that we can add accessories. So this was just using the tools, right? I didn't have to refresh. I didn't have to rebuild anything. It's just running Flask. And we can do the same thing with the front end here. So I'm going to go into our front end, and we'll just do a quick change. I believe I had something. Oh, yeah. OK, so we have hello DockerCon there, and I will comment that out. And let's save. And that was picked up immediately. The title's gone. See, it just happened again because Vite was running in that container. It picked up that the files changed from the host, which are bind mounted into the container, and it just restarts. We can just bring it back in to show. As soon as I brought it in, I didn't even hit refresh, right? Vite handled all of that. That's all working. So we mentioned that there was going to be one other thing that we were going to show here with Docker Compose. And yeah, I'm not going to make it presentation because it'll be hard to come back out. So the first approach that we've been talking about all along is kind of represented in that top picture. You can see that we have the host computer. That's usually where you're running tools like your IDE. And you have your source code there. You're modifying those files. And you want that to be reflected inside your running container, which now has your compiler, your runtime, your linter in there. And we do that via bind mount. Now, in the latest version of Docker Desktop, we have another approach that you can take if you want to use this. So in the second approach, we have Docker Compose Watch. What's basically happening is on the host, you have this small daemon service that's watching your source code. And whenever it changes, it's going to perform a copy on what changed. So let's see what it takes to set that up. We'll just do that here briefly. And I think we're running out of time.
No, it's fine. We have 10 minutes.
OK.
It's fine.
OK. All right. Thanks. So let's take a look at our other Docker Compose file. And I think I got to kill Docker Compose here. All right. We've done that. Let's take a look at the second guy. So in our Docker files, we have another target. And that was just to show the difference. So you can kind of see here side by side, right? In this one, I didn't do any copy command. Why didn't I do a copy command that you usually do in a production environment? That's because we were bind mounting in our source code, right? So we're expecting the source code to be available inside the container. A lot of times, though, you see copy. And that's OK. With Docker Compose Watch, you can do that. So that's the only difference here between these two. With Docker Compose Watch, I'm now copying that source code into the image, the development container image. And we're going to do the same thing here in web. You'll notice that there is OK, same thing. So the difference between dev and then the dev watch demo that we have is just a different target inside our Docker file. And we're copying web into the container. Well, what kind of changes do you need to do with Docker Compose? And just to call out the person who made this demo, Milas, he's going to be giving some other talks just on this exact topic, like when should you use bind mounts, when should you use Compose Watch. If you get a chance to make it, like everything he does is great. He's very, very knowledgeable, so highly recommended. So we had our Compose that we were used to, where we saw our volumes being mounted in. Watch is going to be very, very similar, but we're just going to use that new keyword, develop. So once again, we've got our image, we're building, we select our context, we've selected our new Docker target, or our build target. And then here now we just have this new develop keyword, which is a setting that we're going to pass off to Compose. And we're saying, look, I want you to watch. When API requirements changes, I need you to rebuild the image. And that's because our base image, that base layer, is really the Python runtime plus all of the packages that we need to run. But then our code that we're working on, we're going to use the sync target. And we're just saying, look, if something changes inside API, inside that directory, just copy it into app API. Same thing for web. We see something very similar. So we're using that dev watch target in our web Docker file. And our path, we're going to rebuild if the package JSON or the yarn lock changes, because we want our development image to have all of our package dependencies in there. And then finally, we have our web path. If anything changes in that, if anything changes in our code, sync it in. So how does this work? Let's do Docker Compose and not up, even though muscle memory really wants it to be up. We'll choose this file. If it was Compose, you'd just do Docker Compose up. But since I did it in another file just for demo purposes, I had to select that file. And then we're going to, instead of selecting up, we're going to select watch. So that's the difference here. So we run that. Once again, it says it's running, but you'll notice that we get these little debug messages saying it's watching. So this becomes very, very useful. Let's go back and see with our edits what happens. So if I go to API and we go to app, once again, let's comment out the accessories. So we should kind of see our accessories go away, and they did right there. So we don't have our accessories anymore. The debug output says, look, I'm syncing API after changes were detected. So it saw that file changed, and that little watch daemon that we saw in our graphic synchronize that with your development container. So if I bring that back in and save, you can see, should just refresh, and we've got our accessories again because the API changed. Same thing happens with our web. So just to show, so we'll comment out hello DockerCon, and it just refreshed for us again. And as we saw, it synced that in, just synchronized changes after it was changed and brought into app.jsx. So really, really neat story here. You've got your tools pinned to the right version. It's a consistent experience for other people. Let's take a quick look here then back. I'm going to do, it's FN, F5?
Yeah.
I know I got to move forward again. That's OK. All right, thanks. So just a quick recap of what we learned here. So we kind of saw those two different approaches, right? What did we learn? When I was speaking with Djordje, I'm like, how can we summarize what we just learned in this section? He said, Compose is awesome. And it's true. Like, most people love Compose. It's a great tool. It's really nice to use it in this way in development. And we saw really two ways of approaching our development with Compose. One is by bind mounting in that source code and having all your tools. And then we got this new, shiny, amazing Compose watch, which just came out in the latest Docker desktop. So if you've downloaded that, you'll have to give it a try and let us know what you think. We have a couple more code samples. We really wanted to do a lot more, but man, with time, it's hard, especially when demoing. But if you go to Djordje's GitHub and DockerCon2023, you can see these examples that we've showed off. You can see a couple more. There's one even with Terraform. So if you work with infrastructure as code, you also can containerize Terraform, bind mount in your AWS credentials or credentials from something else, bring in some environmental variables, and then you've got it pinned to the right version of those tools to work with that as well, which is, I think, also a nice story. And if you want some more info, Docker docs are really, really nice. And there's a good write-up here on Watch. Oh, yeah, so we got one more demo that we wanted to show. Do we have time for this?
We have 3 minutes. Let's do it. It's a quick one.
OK.
Last one demo we want to show.
Man.
We wanted also to show you that what we show here today, it's not just us like selling you Docker, like use Docker, please. We're also actually, all of the things that you saw today, we are using it also internally. So actually, Docker itself uses all of these tools, all of these things to develop. So what you need today to be able to hack on Docker is just Docker. So Forrest, who doesn't work, wanted to show you how it's easy to be onboarded on working on Docker itself.
Yeah, and I thought this was a nice story. So he's going to have to talk me through this a little bit, but I think we can go pretty quickly. So we have our Moby project open,
yeah.
And I am going to be now hacking on Docker engine itself, like Docker daemon. So what we do here, with the help of my coworker who's paired with me, since I don't really know what I'm doing here terribly, we're going to add a message when you pull an image. So I'll go ahead and I'll save that file. And let me make sure it's Command S, right? OK. All right. So we're going to do, just like we mentioned, how you oftentimes will end up using make files or just files or task file, whatever it is, whatever your task runner, you kind of wrap the underlying Docker, the longer Docker commands. That's what we have here. So this will be bringing up Docker daemon shell. And then I'm going to run make. No, it's hack. Make, and it's binary, right?
Yes.
Hey, I remembered some of the stuff from our practice. OK.
Yeah, so he's right now inside like our development container that contains everything you need, all the libraries, all the dependencies. It has containerd, run C, so everything you need to work on Docker itself.
And we did demo this a little bit, but I found for myself to learn how to develop in Docker, having a shell inside that container is just super helpful. We'll also have the Docker debug tool that we talked about. It's coming out soon, so that's pretty exciting. So now I'm going to run...
Bundles, yeah?
Yeah, bundles. Bundles, binary daemon, and Docker D. So this is my in-development Docker daemon now. And then we'll do Command T, and I'll make this bigger for everybody. And then now I'm going to do Docker PS to see what are running Docker dev, and I need to
exec then into it.
Exec into that. All right, so Docker exec.
Put it up.
Did I not?
Yeah, it's too way.
Oh,
Yeah,
too small?
No, just Control L.
Control L.
Yeah, so it's up.
I got you.
So they can see, yeah.
Thanks. Yeah, very nice. So Docker exec.
And then the
I forgot what it was
the ID.
now.
You could paste the ID you had.
Yeah, I didn't copy it. See.
Okay.
Okay. Well, at least we're in the middle of the screen.
Yeah.
Docker exec minus IT and Command C, Command V.
And bash.
Yeah,
Give it-
thanks. That's right. So now I'm going into the shell inside that container. Command L will work here? I didn't.
It will.
Control L? There we go, Control L. Command and Control, it gets me confused. All right, so now I'm inside that, and I'm going to do a Docker pull.
You can pull an image now, yeah.
Yeah, so at this point in time, we now have this shell, which is interactive, and it's going to be talking to our in-development Docker daemon. I'll do Docker pull hello world, and you can see we got our message, hello DockerCon, so I'm actually developing against Docker desktop. And so, yeah, this whole story about using containers in development is something that we do at Docker. We find it a very nice experience. So I believe that's the end of our demos, and they all worked. That was great. All right. So thank you guys so much for the talk. We want to. Anybody have any questions? Anything that they would like to ask, or maybe problems that you've had gotchas when you were trying a similar approach?
Okay.
Oh man, that's nice. Thanks. All right, well, thank you guys so much. Really, Docker says one of its virtues is developer obsession. So we want to make developers' lives easier. If there's something we can do better, like, let us know. Also, we just wanted to have a shout out here. We're going to have the Innovation Lodge. There's the Innovation Lodge here. If you can, come chat with us there. We'd love to chat with you. So thank you so much.
Thank you.